Morning. We'll start in about 1 minute. Right, so let's get started. So this week we are going to be talking about 11.5 and 11.6. Well, it's gonna happen for 2 weeks. I'm gonna talk about some parts of 11.5, some parts of 11.6. I think it makes sense to talk about them together. However, your homework is going to be solely based on 11.5 this week and solely based on 11.6 next week. So if you see some problems that we didn't cover today in 11.5, just treat it like a preview. Next week we'll for sure talk about it. But you know, sometimes it's good to have preview and try it on your own first before we talk about it in class. So we'll just to let you know, if you see some problem that we didn't cover in class, then you can know that it will be covered next week. Okay. Now, speaking of which, today we're going to talk about volume. I'm going to calculate volume of it's actually 4 different kinds of shapes: prism, cylinder, and then we're going to talk about pyramids and cones as well. Okay. But pyramids and cone was included in 11.6, but I feel like since it's so similar, I would include that in today's lesson as well. Okay. Calculate volume of prism and cylinder. Okay. All right. So this is the 14th. Is that right? 14. Okay. So look at this. So what is a prism again? Prism is when you have the same base on both sides, right? Like you have 2 bases. And to find the volume, what is volume? Volume is basically how much space you can contain within the 3D solid, right? So how much can I contain? Now, before we talk about 3-dimensional, we talk about 2-dimensional first. So if you look at the base, in this case, the base is a triangle, right? So within 2D space, this much is contained, right? This is how much I contain. Now, if I want to project this into 3D world, then naturally I will use whatever I can contain here and duplicate that, or duplicate, I mean like stack it up, right? Accumulate from here all the way up to the very top. That way I can know how much I contain. So therefore your volume is going to be whatever your base is times the height. Okay, whatever the base area. So it's base area times height. Think about this as like, your sticky notes or your post-it notes. Don't they have like a stack, right? Stack, and they're all the same size, right? For the most part, or most kinds of post-it notes, they have the same size of the base, and then it stacks up. The more post-it notes you have, the higher it gets, right? And the more volume it has. So volume is like stacking areas together. Okay, this concept will follow you all the way to calculus. I'm going to use something like that to figure out the volume in calculus as well. Okay, so keep this in mind. Volume can be treated as a stack of areas. Okay, obviously you need some sort of thickness, but in terms of concept, right? So knowing that volume is base area times height, you can also find that these two special prisms, one is rectangular prism, the other one is also rectangular prism, but this is a cube, right? Cube, so all three sides are congruent, or all three dimensions are congruent. So if you look at this, no matter which two bases you pick, it's always going to be length times width for the base area times height, which is the height, right? Base area times height. Base area here is the square, so it's s squared times height, which makes x cubed. Make sense? Base area times height. Okay? Now, let's look at the problem. So, like we said before, prism doesn't have to be upright, which means that it can slant. As long as you have the two bases are consistently throughout the whole prism, then you're fine. So, what is this? Volume equals base area times height. So base here, because they say it's a rectangular prism, so we know it's a rectangle in the base. Rectangle is, length times width, right? So 3 times 4, that's your base area. What's the height? They tell you this is 1.5, so just multiply 1.5, so you get what? 18. Now, you're doing volume is 3-dimensional, so feet cube. Make sure you have this cube here, okay? How are we doing? Should be quite simple for now, right? Cool. Let's look at the right side. So the right side is a hexagonal prism. Hexagon, right? Hexagonal. So hexagonal prism is a hexagon that you basically so it's the same thing, right? You gotta find base area times height, right? But the base area here is what kind of shape? Regular hexagon, which is what we have done before. Remember how to do this? You have to find the base area of this. Okay? Base area of a regular hexagon. Remember how to do it? Type it in the chat if you remember how to do it. Type it in the chat. Split into triangles. Okay, here we go. So when you split into a triangle, right, you get a 9 here, right? And then you remember we were trying to find the apothem. And because we want to find the apothem, which trig value do we use? Do you remember? Or you don't even have to use trig values. 3 root 3 over 2 a square. What? How do you get that? Remember the setup? We did this like a couple of weeks ago with base area, right? Remember which trig value we use? 4.5 over A, right? Tangent. Opposite over adjacent, okay? Opposite over adjacent. Also, how do I know this is 30 degrees? Because the whole thing is 60, right? You have 6 triangles total, remember? 6 triangles, split into 6, each one is 60 degrees, okay? So, knowing that, now the next thing is to find tangent. So A is, apothem is 7.794, okay? So that's, you can divide by tangent 30. Tangent 30 is less than 1, I think, 1 over root 3. Okay? Or, I mean, if you're good with 30, 60, 90 triangle, this is 30, 60, 90. So this is 4.5, this is 4.5 times root 3. Okay? So you can get that answer with that as well. Okay? Okay, so now area, right? Let's not do area. Base area is then 1/2, right? 1/2 base times height, 9 times 7.794 base times height, and then there's 6 of them. So if you multiply them out, get 210.44. I don't think it's 218 there, but I'm not sure. Do you get what the apothem I get? So volume is base times height, which is 210.44 times height is 12, right? So together is, what happened, Darren? Maybe you're right, I'm wrong. I don't know. Can you tell me if, so this is what I got, 2525.3, right? Because I got, let's see, let me just double check. So first of all, you get 4.5 divided by, this is tangent 30, right? So that's at 7.794, right? Whatever this is. I multiplied that by 9, multiplied that by 6, divided that by 2. Yeah, 210.44, right? And times 12. That'll give me my answer. I'll round to the nearest tenth, right? So it's the same thing as before, except you have one more dimension, so you have to multiply by height when you want to find the volume, because I said volume is a stack of area, right? Or you can treat it as a stack of area, okay? All right. Next up, let's look at the left side. This one. So, volume of composite figure. So, composite figure is when you have more than one solid. Composite, right? You know, a combination of things. Composite. Right. Kind of like chemistry. Composite. Yeah. Okay. So anyway, we want to find the volume of this. So this is a hollow inside. It's not very obvious here, but it's cut open here. So it's like, to find volume, you would use a cylinder minus the rectangular, or in this case, it's square. It didn't say it's square, but it is square. Okay, this is a square. Square. Okay. All right. You want to subtract that. Okay. All right. Moving down a little bit. So to find this, both of them are prisms, so it would make sense to make base times height minus base times height, right? Or base 1 times height, base 2 times, they have the same height, okay? So how do I find area of base area for circle? Isn't that Remember area of a circle? Pi r square h, right? Pi r square for base area of a circle. Radius is 3, right? So pi r square, 3 square, h is 5. Now the problem with the second one is that the second one, it's a square, but they didn't give you the side length, right? They give you the half the diagonal, right? They give you this. Now, because it's a square, we have many things to use. First of all, if you know this is a square, right? This is 3, this is 3, this is 3, this is 3, right? So once you find this length, then you're good, right? Because you find this length, you just multiply these because they're all the same side length. What angle is this angle? What kind of angle? $90. If it's 90 degrees, then naturally this is a right triangle. Then we can use Pythagorean theorem to find this length, right? That's one way to find the area. The other way is that since I know this angle and I know these length, I can also use, remember your area equals 1/2 AB sine C? You can use that formula to find the area of this triangle n times 4. That's also a way. I don't know which way you use, as long as it gives you the area. Then I don't care how you do it, okay? If you want to use Pythagorean theorem, then you would get 3√2 here, or square root of 18, or however you do it. Special right triangle also, right? This is a 45, 45, 90. So 3√2, 3√2. So when you multiply this, the whole thing here will be root 18 times root 18, so that's 18. Okay, so base area is going to be root 18 square, which is 18. Okay, that's one way to look at it. Another way, if you want to use 1/2 AB sine C, sine 90 is actually 1. So same thing as 1/2 3 times 3, which is 4.5. So times that by 4, you still get 18. Okay, no matter how you do it, you're going to get 18. Okay, so it's 18 times height is still 5. So you multiply and then subtract. Your calculator. What do you get? Uh, 51.4 units is in centimeters, but it's 3 dimensions, so cube. Okay. How are you doing? All right, so you try one. Same thing, this is a hollowed inside, so kind of like same thing. So while you try, can you tell me if you're here so I can take attendance? Just for formality. Kind of already seen most of you, but for people who haven't talked yet. Got an answer yet? Type it in, type it in. $763. Did you multiply by 12? Um, 243 or 9160.88 is correct. Or 0.8, 0.9, yeah. So, volume is pi r square h, right? Pi r square. R is 18 square. H is 12, right? Base area times height. Base area is a circle. Base area is another circle, pi r square. Height is 12, right? And then you just calculate this out. I think it ended up being 9160.9 feet cubed. Oh wait, not feet. What? What's the unit? No, it's not white out. Well, it's not feet. Okay, it's inches cube. Inches cube. Okay, inches cube. No, I found it. Too bad I don't need it anymore. Okay. That's that. Comfort level 1 to 10. How are we doing? Anyone seen Alex? Alex, are you here? Okay, 7 to 8 is okay. 9, 10 is good. All right, so let's flip it over. So next part is prism, pyramid, and cones. Okay, so why do I say they're similar? Because, well, first of all, pyramids and cones, what's that? Prism and cylinders are the same thing. Pyramid and cones are the same thing in terms of finding volume. Okay, Keza Gomez, are you Alex? Where are you? Why use random names? Who's Zika Gomez? Anyway, so welcome Zika, I guess. I don't know who Zika is. Anyway, so we got volume. Well, calculate volume. Pyramids and cylinders. Okay. So we are at all right, so take a look at this. What we have is, so would you agree with me? Pyramid to the relationship of pyramid, I can't spell pyramid, to prism is the same as cone to cylinder. Well, they're essentially the same thing, so it makes sense, right? So there is a exploration type of proof, not really proof, but there's exploration in the book that's easier to see if you just read the book than me telling you about it. Is page 635 to 636 in the book. They tell you why, or they attempt to explain why the volume, okay, the volume of a pyramid is going to be 1/3 the prism. Okay, they tell you why it's going to be 1/3 the prism. It's some sort of sandbox experiment where they fill the pyramid with like sand and they dump it into a prism, and then they end up getting 1/3 of it, and then they did another one in the next page, which is kind of like compartmentalizing the volume, that type of deal. Okay, so anyway, we're going to use it for now. Okay, so example problem. So this is a hexagonal pyramid. Your volume is naturally 1/3 base times height. So they didn't tell you the height, but they did tell you that the height is equal to the apothem. So height is apothem here, okay? But I haven't found the apothem yet, right? So you got to find the apothem first. So let's give it a little bit. So we're going to do that again, right? But except that this time is 12. So repeat what you did on the previous problem, but with 12, okay? Can you find the base area of that? Once again, right? 30 again, right? And this time is 6, okay? Tangent, right? Tangent 30 degrees is equal to 6 over A. So A is 6 root 3, right? Gets 30, 60, 90, which is, I'll naturally remember that this is how we get 30, because you have 6 triangles, right? Divide by 6, you get 60. Divide by 2, to get each one, you get 30. And then you do 10.392. Okay. I keep one more decimal place just so that when you multiply it, it will work. Okay. All right, and then we'll go ahead and do the area, or the base area. Base area is going to be 1/2 base 12 times height, which is 10.392, right? Base is 12 times height, times, there's 6 of them, right? So if you multiply this out, you get 374.11. And then your volume is 1/3 base area times height, which is the apothem, right? Apothem. This is the height. Okay, I'm gonna put, this is base area, this is height, okay? Base you already found, which is this. Okay, multiply this out. So 1295.9 feet cubed. Okay, so recap. Still base area times height, but it's just 1/3 of it. Base area we already knew how to find, so it's just a matter of executing it correctly. Make sure you find the apothem if you want to do it that way, right? So if you find the apothem, then it's 10.392 or 6 root 3 based on 30, 60, 90. And then once you get that, you use the same method to find base. 1/2 base times height times 6. And then once you get the base area, the rest is, they already tell you height is the same thing as apothem. So if your apothem is correct, your height should be correct. And you multiply it through, okay? How are we doing? Good. So next one, you try, right? You try, this is a regular triangular pyramid, and this is base length is 12, right? And the height is 10. How is the height is 10, right? Now, since it's already a triangle, we don't really have to break into more triangles. Can you tell me what is the angle here, if this is an equilateral triangle? $60 is correct. So since I have that, I don't have to bother with the apothem anymore because, you know, I know this angle, I know these two sides. I'm gonna review base equals 1/2 AB sine C, or base area, right? The area of a triangle is 1/2 AB sine C. So it's 1/2 12 sine 60. Okay, SAS, right? SAS. This is a formula we learned in trig chapter 9. Okay, you use this when you have side angle side given. So base area turns out to be 62.353. Right. And I'm going to use this 1/3 base area times height. Right, base area times height, which is 1/3 base area 62.353. Height is 10. Okay, multiply it out. 217.84. Is that inches cubed? Okay. All right. Okay. Last part is cone. Cone we already talked about is the same thing as pyramid, so it's still 1/3 base times height, except your base is obviously a circle, so you get a pi r square here. Okay, so you get 1/3 pi r square h. Now, last two problems, you can see that it's also composite, and they're made of multiple different solids. They're all adding instead of subtracting from the previous section. So, first of all, we got to find all the heights first. This is 70, this is 35, so you got to cut it here to get this part, which is 35, right? And notice it's not symmetrical. There, I have everything I need, right? So now I'm just going to calculate solid for each of the three, okay? So this is 1/3 pi r square h, which is 35, right? 1/2 base area is 21 square pi, right? This one, cylinder, no 1/3, okay? R is still 21 square. They're all 21 in radius, okay? 35 in height. 1/3 pi 21 square. This one height is 40. How are we doing? Then you add them up, right? Add. You should get an answer. Okay. So what do I have? So you round to the nearest 10, right? It's a big number, I think. (83, 126.5 centimeters cubed). So that sounds about right. Does that sound about right? Yeah, great. Last one. They want answer in terms of pi, right? So this one you don't have to multiply the pi out, just leave the pi as is. But this is very similar, right? So try that real quick and give me an answer. Leave it in pi, okay? Leave it in pi, which means your answer should be something pi. Okay. Give you 2 minutes. Oops. think you're right, Darren. I think you're right. So top one, right? 1/3 pi. This is a cone, right? So 1/3 pi r square h plus the bottom one is a pi. R is 24 square. H is 18. So to leave it in pi, you just ignore the pi until after you add them up. Okay? So you add them up together. Without the pi, you get 10,800. And because you can factor out the pi, you can multiply pi in the end. Okay? And this is in yards cube, right? Yard cube. Okay? That look right? So your homework, like I said, it's on big ideas. 11.5. This is due Sunday, of course. Sunday. Okay. Make sure you do them. Keep up the homework is important. Any other questions before I let you go? Are we okay with this? We got a good comfort level. By the way, is Alex here? Is Zika Domus Alex? Who's Zika Domus? Chapter 11 tests will not happen until Tarun? Okay, so it's not Alex. So Alex is not here. So Alex, if you're watching a video, make sure you send me an email afterwards. Okay? Alright. So anything else before you guys go do your homework? So who's Zika Domes? Huh. Anyway, Zika Domes, if you're not in this class, then welcome you to continue to stick around. But that must be Alex. But Alex is not revealing his identity, so it's hard to say if it's Alex. Oh, you guys would know all about Fortnite YouTuber. But I need to pause it. Oh, it is Tarun. Okay, so it's not Alex then. Alright. That settles. Okay, so so we're good then. See you next week. Okay. Give you a little bit of upbeat music. So feel free to leave. If you have any questions, I'll be here for another minute or two. Bye. Bye-bye. Oh, hi Alex. Great. Yeah, I got you. Yeah, to comment you have to log in. Goodbye.